Hello, in this week's videos, I'm going to be teaching the calculations in linear expansion. So before we solve this problem, let me quickly show you the formula that we will need for our calculation. So we have linear expansion, which is given as L2 minus L1 divided by L1 multiplied by change in temperature, that is T2 minus T1. Let me quickly explain what each of these letters stands for. Okay, so we have L2. L2 stands for the final length. So, final length of the material. And we have L1. L1 is the original length or initial length. So in this case, let me just use original length. If you want, you can call it the initial length. And then we have T2. T2 is basically a final temperature. And T1 is the initial temperature. So initial temperature. So T1 is initial temperature. Now, looking at these formulas, we can rewrite this formula as L2 minus L1 is change in length, like this, divided by the original length times T2 minus T1 is change in temperature. So we can write it as this, change in temperature. Now we can find the linear expansivity of any given material by using this formula. So let's quickly solve this problem. A metal of length 17.02 meters is heated until its temperature rises by 80 degrees Celsius. If its new length is 17.09 meters, calculate its linear expansivity. So to calculate the linear expansivity of this material, we are going to apply this equation. But let me quickly explain this. So this is the original length, so we can call it L1, which is 17.02 meters. When heat was applied, it increases to 17.09 meters. So we can say this is L2. Now let's quickly solve this problem to find the linear expansivity. So we have this equal to change in length is L2 minus L1. So we're having L2 minus L1, 17.02 divided by L1. So we plug in what we have, 17.02 is L1 times change in temperature. Change in temperature is given as 80 degrees Celsius. In this case, therefore, if we subtract this from this, we are going to have 0.07 and then divided by 17.02 times 80 from the calculator, we are having 1361.6. And then if we further divide this by this, we are having 5.14 times 10 raised to the power of minus 5, and the unit is going to be per Kelvin. So this is how to calculate the linear expansion of a material. Thank you for taking your time to watch this video. Other examples are still coming in this week. Please like this video, share it with more students, and if you are not following this page, endeavor to do so for more updates. Goodbye.